Hi everyone, my name is Wilnelly Ventura-Valentin and I'll be presenting my research on the characterization of swarm and aftershock behavior in Puerto Rico. This work is done with Dr. Mike Brudzinski at Miami University. It all started with the Indios Puerto Rico seismic sequence that began on December 28th and still remains active. The largest earthquake of the sequence occurred on January 7th and was a 6.4 magnitude event. The sequence is very interesting because it presents a mix of both mainshock, aftershock, and swarm characteristics. If you're not familiar for the location of Puerto Rico, it's located in the Caribbean. As a result of the unprecedented nature of the sequence and in an effort to understand it, we decided to study all previous sequences. A detailed characterization would provide critical input for aftershock and swarm forecasting, and therefore become a key component for better hazard mitigation in Puerto Rico. We began by looking at the characteristics of both types of sequences, using a timeline-style plot of magnitude of events versus time to look for the sequences. After finding the sequences, these were characterized by looking at their behavior. For example, if the sequence had a clear triggering main shock and a clear decay of events over time, it was characterized as main shock aftershock. But if the sequence had no clear main shock and the events were around the same magnitude over a period of time, it was characterized as a swarm. By adopting techniques from previous research by Holtkamp and Brudzinski, we developed criteria that consist of looking for a clear main shock, number of events around the same magnitude and duration of the sequence. We also considered the abruptness of the sequence compared to the background seismicity. An undetermined classification was made because some sequences didn't have enough data to be considered for one or the other. Using previous research as a guide, we tried distinguishing swarm and aftershock sequences based on this plot, where the number of events are on the y-axis and the largest earthquake in the sequence are in the x-axis. Because swarms have more events per largest event magnitude, it creates a divide between the two sequence classifications. As you can see, swarms stay on the left, while mainshock aftershocks stay on the right. Applying the previous technique to our study region, we identified 73 swarms and 25 mainshock aftershock sequences. As you can observe in this plot of number of events versus largest magnitude, all sequences since 1980 are plotted, and we cannot see a clear divide between the two classifications. Swarms generally have larger numbers of events per maximum magnitude, but both classifications still overlap because most mainshock aftershock sequences start roughly around magnitude 4. The plot on the left is the same plot I just showed you in the previous slide. The one on the right shows all sequences since 2015. A better separation is achieved when focusing on recent sequences, suggesting that something is working better in the recent dataset. We can hypothesize that this is due to better recording based on increased number of seismometers. But we can look more into this in the next slide. We divided into 6 geographic regions, as you can see on the map. Out of the 6, only 4 regions had seismic sequences to be analyzed. Each regional subdivision showed a clearer separation between the two sequence types. We can now see the same regions showed before, but now plotted with respect to the depth and local faults. We can observe that northern regions don't follow the local faults and show greater depths, which is consistent with a relationship with the offshore subduction zone. However, earthquakes on the southern region have shallower depths and follow the faults. Southern events are also better recorded by the Puerto Rico seismic network. Therefore, magnitude of completeness varies over time and geography. Higher magnitude of completeness in the northern offshore regions create artificially lower numbers per sequences, while lower magnitude of completeness in recent times due to increased recording creates higher numbers per sequence and more sequences. Together, these prevent a simple effective metric to distinguish when combining sequences across the various geographic regions and the time frames. To summarize, the 2019-2020 Indios sequence is a mixture of swarm and Mainshock aftershocks. We identified 73 swarms and 25 aftershock sequences that can be used to help forecast future sequences. The ability to detect swarms has been variable over space and time due to the changing magnitude of completeness. If you have any questions, you are welcome to participate in the Q&A session. If you're unable to attend and you would like to know more about my research, you can email me. Thank you for your attention.